Okay, shall we start? So good morning, everyone. Thank you for everyone that has joined us so far. I'm Daniel Chamorro, and I will give a brief introduction about Sintu to those of you that don't know Sintu. I have a special guest today, Giorgia Rossi, who will be with us and showcase some of their solutions.
Hi, Daniel. Hi, everyone.
We will have a section towards the end of the webinar where we will be answering your questions. Feel free to write these questions during the chat. If there's a lot of questions, we can also answer them during the session. But in any case, if you have some very detailed questions that you would like to ask about Sintu or about the Excel solutions, towards the end, we have a dedicated slot for you to talk to us. Okay. So a bit of a background about Sintu. Sintu started in 2013 as a result of research to be able to stream large point clouds converted to mesh in the cloud, right? And this translated into the company being set up in 2018 in France and also the US. And today we have expanded our presence. We are around 85 employees. And we have a very powerful solution to help customers work with their reality data. When you talk about digital twins, that is a word that I believe many of you are familiar with. Sintu is serving two main segments that use this methodology of working with digital solutions. So customers in the industry, or what is called Industry 4.0, right? And then the other segment in the AEC or AECO. Now, I believe that many of you have heard about digital twins, and you probably are aware of different interpretations of digital twins, right? This is a very interesting graph because for some people, a digital twin could be a point cloud or could be just a photo, right? Or a result of some photos, right? So it's important to understand what is a digital twin when we talk about standardization and understand how a point cloud coming from your laser scanner, right, is actually just one of those layers, right? There's several layers. And in this graph from the Institute of Engineering and Technology in the UK, you can see that the point cloud data, or what is generally known as reality capture data, right, is in element 0. And element 1 is when you have a model, right? And neither one could argue is the digital twin, right? There are different layers, and as you add those layers, the reality capture obviously being the foundation of that digital twin, then you have a really powerful solution that can really optimize your workflows, right? In the context of Sintu, as you see on the top right, what we allow our customers to work with is 3D scans. Obviously, that's the solution that Sintu developed. And we can also display the 360 images that come with your scanner, or also separately. We also allow you to display your 3D models with the metadata. We have some interesting solutions for you to tag your assets, which I will discuss later on. And you can also plug into Sintu with our APIs. Now, the challenge that we have seen today with working with reality capture data is a very old challenge, right? There's the design or the design intent, right? And then the laser scan data that brings you how are the as-built conditions, right? And this gap between the two is what technologies such laser scanners and some of the solutions that we will be talking about help you to really get the geometry of the real world, right, into the digital world. So if you're struggling with your digital transformation, laser scanning or reality capture is really the technology that allows you to bring the geometry of the physical world into the digital world and start working with that data. Now, one of the main challenges that we've had with this technology, and all of you that have worked with laser scanning for some time will know, that these scans or the technology itself, the 3D laser scanner, have been around for quite some time, right? It's not a new technology, even though many of these vendors will say, oh, revolutionary, game-changing, etc., right? It's a technology that's been around quite some time, but as the technology evolves, it's always getting more accurate, it's capturing more data, and more data generally means more problems, right? However, some of these problems with data that we see, or we still have, many of our customers have, can be overcome with SINT. If we look at a typical project, whether we're talking about an industrial site or a large heritage survey, to have an example of pretty much what customers face today, one site, sometimes especially in industrial, or specifically we're talking again, as I mentioned, with heritage, you could be dealing with a lot of data, right? And a lot of data is very problematic in terms of managing, in terms of collaborating, right? And in terms of being efficient with your project delivery. Now the data volume or the data size of a point cloud, I think we can agree that it's a problem that is going to continue, right? The scanners that you see today are not getting any less accurate or capturing any less data. They seem to always be capturing more data, more scan resolution, etc., right? So this problem continues. And the point clouds in general, as most of you have already seen, require some training in order to navigate them, in order to make annotations, etc. So it's not a technology that is for everyone. Requires some learning, right? And additionally to these two problems, the last, let's say, additional problem that customers have as a consequence is the collaboration or the limitations that these problems bring in terms of how you can work with other teams. And in today's world that everyone is working with different teams, with different partners or subcontractors, this becomes quite critical, right? What SINTO technology has allowed, because we create a mesh out of your data, and this is the core technology that's actually patented, is that we take your scan data and we mesh it. So on the image that you see here on the left, it's a typical point cloud, right? If you're just navigating the point cloud. And then what you would see on the right is the mesh. Now, the mesh obviously is much easier to stream for SINTO with our own technology, right? But it's also 10 to 20 times smaller when we're uploading the data, right? And the interesting thing about this is that we can also, as part of our patent, we can also reconvert the data back to a point cloud in different formats, eFT7, RCP, POD, and so on, right? And this becomes very important because once you upload the data, we're not asking you to mesh it, or there's no additional step. It's already meshed. Whatever you see in SINTO, it's a mesh. And the interesting thing is that it's a mesh at the quality of your scanner. So whether you start with an entry-level scanner or a high-end scanner, you can appreciate the quality and start working as well with different tools that SINTO's platform delivers. Now, as I mentioned, the second problem SINTO is addressing is the collaboration component, right? Now, making the data available in a mesh format is part of how we're addressing the challenges, right, of interpretation and the complexity. But how SINTO has offered solution in a way that customers can work with many stakeholders. There's no limitation, users, projects, in meshing your data, in downloading data. Once you get a project in SINTO, you can add different coworkers, different stakeholders, give them different permissions to work with the data in any location, and then work in a secure platform, right? SINTO has been certified for SOC Type 2, and we recently got our ISO certification last year. And we're also giving customers the option where they want their data located. They have options with Azure, Google Cloud, AWS. And this allows customers to be fully in control of where the data is hosted, in which geography, and so on. Now, another challenge that comes with point clouds is that, as most of you have seen, point clouds started in different, coming into the construction industry in different ways. In terrestrial scanning, they also evolved into SLAM, right? SLAM scanners, which we will talk about today with Gexel. And we also see them coming into drones, right? Drones started making a trend with photogrammetry, but as the technology of scanning got more democratized, many of these drone companies started integrating LiDAR sensors as well. And then another interesting development in our industry is the 360 panoramics, right? So we know that reality capture data is laser scanning. It's just one element of reality, right? And 360 panel images also bring additional layers of information. And there are many players. I honestly cannot fit them all on this slide, but you will see on the top that the main laser scanning providers for terrestrial. On the right, you see some vendors of SLAM systems, such as Gexel, and on the bottom, some vendors for 360 cameras, and on the bottom left for drone systems that deliver sensors with laser scanning as well as also other kinds of modality, right? Why is this important? Because when you're working with laser scanning, usually you start with one system and then you complement it with another, right? And usually these vendors that we see in the market, and they have their own solutions, right? And for our customers that want to have a very complete workflow, they want to merge different kinds of data from different sensors to be able to work in SIN2. So we've allowed this automatic process in which we restructure SLAM data. We can also restructure automatically drone data. And we can, of course, display 360 images. That's something very simple, almost anyone can do. So that's very important for customers to have this multimodal platform that can support all their reality data. Now, as most of you have heard about the term of BIM federation, right? How you can federate all the different kinds of data for BIM for different use cases. SIN2's approach with reality data is focused on unifying in one single platform, in one single viewer as well, different kinds of digital reality data, right? So whether we're talking about point clouds, whether we're talking about the scans, right, the 360 images, the asset tagging functionality that we have, obviously the 2D model. All of that is displayed in the same viewer, overlapping each other into like a split screen. So it's really about collaboration and helping our customers get the most of their data. Now you could start using SIN2 as a reality data platform where you collaborate, where you use it for viewing or for measurement, for giving access to a job that you've just completed, right? Or if you want to navigate to a certain location to show your customer that you've completed a project or so on. There are different ways of using SIN2 as well as for data distribution. That's another use case that SIN2 allows, because you can always download the data back to a point cloud, or you can download it into a mesh. There's also a use case that many customers ask us about virtual tours or 360 tours. Displaying 360 images is something very simple. So of course you can always do that in SIN2 and just use a viewer or a shared viewer of this data and give it as a link or add a different user to that project. Then we have other use cases which are like the scan. Instead of scan to BIM, I like to call it scan with BIM, because it's about working with these two data sets, right? So customers will be uploading their point cloud data and their models, and using our tool that many of our customers really like, we can display the differences between the design and the as-built conditions, right? And you can do simulations. We have a new VR app that you can use as well for that. Factory layouts, progress monitoring. It's another very interesting tool that we announced in BIM World Munich. And on the right, you will see more industrial workflows. Here, we're not talking about so much about the modeling, but more about identifying different equipment automatically. This is again a tool that has been constantly developed, and we just added the capability to detect different objects in your point cloud with via geometry. So we're talking about pipes, talking about surfaces, and so on. And this can be done automatically on your data without you having to do this kind of very boring work. So a lot of that there for you to test. Today's session will be covering mainly from Gexel. So I still wanted to give everyone here a quick overview of this. And you're welcome to request a trial from Syntu. So in summary, this is what most of our customers really appreciate from Syntu, how they have one platform for all their reality data, right? They can use their scans, they can use models, and it needs to comply with cybersecurity requirements, right? Then is the capability of Syntu to be a base solution, so it's available on any device that has a web viewer, right? And we have unlimited users. That's very important for customers. We're not charging you for any amount of users. When you download data and you upload data, have to pay tokens. You want to mesh it, etc. Right? And then the data security and the data management is very important. I mentioned this before. Syntu is at the leading edge in this specific segment in terms of cybersecurity. This is very important more and more in today's world to have your data secure. Who has access to your data? Who the last person accesses the data, right? It's valuable information, so it's actually more secure in situ than you keep it in a drawer or in a computer that anyone access, right? And the no seat based pricing and pricing by scan volume. But what do we mean by that? Syntu is priced by scan position. So you start with 1,000 scans, and then you can keep at 1 scan per Syntu is a scan position. If you come from the terrestrial world, you will understand the scan positions, right? And SLAM data or drone data will be the same, except that if the drone or SLAM data, we restructure it. We restructure the data, create virtual viewpoints along the trajectory, and those count towards your subscription. So before I pass it over to Georgia, I will highlight this QR code where if you want to trace into, feel free to request it, and you can submit your details there, and we'll be happy to help you with your trial. So with that being said, I hand it over to you, Georgia.
Thanks a lot, Daniel, for the introduction, and thanks a lot for inviting us to join this webinar. I'm Georgia. I am almost 17 years in Gexel, and I take care about the worldwide sales market here. And I don't want to bother you about who we are, but just a few words about Gexel. So we are specialized in developing a solution for 3D data acquisition, processing and analysis solution. We have started also many years ago, around 20 years ago, working in these sectors, and we provide solution for surveyors, engineers, architects, so to all the different professionals that also Daniel underlined before while explaining this Syntu Cloud platform. Why choose Gexel? We provide versatile solution because we provide software for data processing, but also solution for data acquisition. And we will be focused on our mobile mapping system today and how Aaron and how it will be integrated in Syntu Cloud. We also strongly believe in this integration. So during the presentation, we will really emphasize how it's important for us, this topic of the integration, as Daniel has underlined. So the possibility to integrate different devices, different data, because the users start working with different sensors that in most of the case needs to be integrated each other to satisfy and also to solve specific need and specific problems. And our solution are trusted in different applications from construction, geospatial, mining, heritage. So we will try to enter inside all this dynamic. So I have a question to you guys. What do you expect from 3D reality capture? I can tell you what I expect and especially what I love. First of all, accuracy. I want to have high accuracy when I am capturing spatial data. And I also want to have reliable measurement. I want to have something which is easy to use and also really portable. So I want to have a very user-friendly interface while I am working on site, but especially while I am post-processing the data. And I want to also have something which is lightweight and portable almost everywhere. I want to be fast and efficient. And this is, I think, one important thing, because being fast means saving time on site, but means also saving money, because time is money. So I want something that can speed up my process on site, but also my process during the data post-processing. I want to be versatile, because I'd like to have a system that I can use in different configuration, in different environment, while walking, while driving, upside down. I want to integrate my solution, and especially I want to integrate my data and my different devices that can be SLAM system, mobile, TLS, photogrammetry. I want to also have the possibility to have something which is customized. So in case I have some specific needs, I want to have the possibility to customize it, but especially I want to be free in processing the data case by case, okay? Because every survey is a case by case one. I want to have a solution that can work in real time, of course, on site. I want to see what I am scanning, but I would like also to see, for example, real-time comparison. So if I have a reference model that could be a point cloud that has been done in a certain period, or even a BIM model, I want to have the possibility to see in real time the differences between what I am scanning now and what I have scanned, or between the as-built and the as-design. I want to have, of course, a reliable solution. Something that can be also, we can say, scale depending on the project and on the needs. And of course, something that is also affordable. So by a competitive price in terms of a solution. And when I talk about solution, I talk about, of course, something which is made up by hardware and software. So how it is possible to have all this kind of, we can say, wish list that I think mine are common, I hope, with yours. I think that the SLAM solution can really fill this gap. It's really a game changer in this sense, because it's portable, it's fast, it's accurate, it can integrate different kind of data coming from the different device. And here is where we can put Aaron. So Aaron can meet really we can say that it can meet the wish that I have introduced before, and also even more. And I want to now take a little bit closer look inside Aaron. Aaron is our SLAM-based system. It integrates LiDARs with 32 lines. It can reach a range in between 100 meters and 300 meters. It integrates an IMU and also a panorama camera. All the system is provided by a rugged backpack, so it's very compact. It includes internal battery that can work for around 1.5 hours. And of course, you can enlarge the battery working time of the system. The backpack, and this is what I love, it is used for transport and also for mapping. So you have something which is very lightweight, because we are talking about less than 7 kilos, that you can move everywhere. Aeron is portable. It is equipped by a different kind of accessory. So you can use it backpack, you can mount on rover, on car. You can also mount it on telescopic pole in order to reach a higher area. And you can use it also upside down. So if you have underground facility, you can easily use Aeron oriented as you like. If you see here, it can be packed, everything in this rugged backpack. So it's very convenient also when you have to travel, because you don't have to ship anything, okay? It's very versatile in terms of application, because it can work indoor, outdoor. It does not need any kind of calibration procedure or initializing procedures. You do not have to close the loop, and you know how this is important when you work on site. It supports the usage of control points, and then I will try to open a parenthesis in this. It is used in underground application, stockpile. You see this telescopic pole that can reach up to 6 meters. So you can really go almost everywhere. The other, I think, important thing is that, as I mentioned before, Aeron is a solution. So it's made up by a hardware and a software that cannot be divided. And the software that are provided with Aeron are very professional software. We use our own SLAM patent algorithm, and the software are desktop software. So you are totally free and independent to work with your data wherever. I will open then a parenthesis also on the software which are provided with Aeron. And what I want to underline is that with Aeron, you have the full control of what you are doing, because you have some different parameters, some setting with whom you can play, you can customize. So you are totally free to carry on the data post-processing as you like and as you need. Just a very small parenthesis about the control points. Aeron support the usage of control points, okay, to enlarge and to increase the global accuracy, okay, of the project. Control points that then can be ground control points, target. We support also the control points on the ceiling. That is a little bit important, but the other important thing is that we can even recognize some control points in the point cloud, okay? So during the processing, I can recognize this point. I can use also some coordinates which can be extracted, for example, from some sketches or from some drawings. But really, I think the unique thing is that we can use scans as constraints. So instead of using the control points, we can use the scans, any kind of scans, it does not matter. We put the scans in the SLAM algorithm process, we keep them fixed, and we can use all these scans to better optimize the Aeron survey. I mentioned before about the data integration, and with Aeron, you can integrate data coming from different sources. So car, photogrammetry, drone, TLS, bathymetry as well, satellite, GNSS, total station. So with Aeron, you can really, we can say, follow all your workflow and using the different data coming from the different devices. One thing that we mentioned before, and this is one of my wish, is having the possibility to work in real time. Of course, during the mapping, I want to see what I am scanning in order to be sure to have covered all the area. But one thing is that you can really also see in real time the differences between a reference model and what you are scanning now. So basically, you can use a reference model, a beam model, or a point cloud as reference. Aeron can track its own position, just comparing geometries. And while we're moving, you can display what you are now displaying on the screen. So green are the area in which you have, we can say, no change. red are the area in which you have changes. And you can select the change that you want to see before you start this analysis. The point cloud of the change is not only visualized, but it is stored on your system. So if you want to run further analysis, like here, diagrams, histogram, or you want to make deeper comparison, you can do that because you have physically the point cloud. So we can say that Aeron is not just a tool, but it's a versatile, really high performance solution, which is designed to satisfy many the different needs of different projects with ease and precision. Just a very fast showcase about the real world application that also Daniel introduced before. So industrial plants, multi-sensor project, BIM and construction, touristic route, for example, 2D.5 maps, underground minings, galleries, tunneling, park and garden, stockpile volume. And this is something nice because you can walk around the stockpile, but you can even mount there on the crane. And so you can automatize all your indoor stockpile acquisition, cultural heritage, digital twin. So really, you can spread between the different application very, very easily. How does it work, the workflow of Aeron? So you go on site and we start scanning our reality. What we acquire is a complete data set because we acquire LiDAR, so point cloud, control points, RGB information, because what Aeron acquires are, let me open just a quick parenthesis on that. Aeron can acquire pictures in 8K by single shot or in continuous streaming. So we acquire a movie in 4K. And we use these 8K pictures or the 4K streaming to colorize the point cloud, but also to create the virtual tour. So then later to enter inside the digital twin worlds. We can also take annotation. So while you are scanning, you can populate your survey by some annotation, for example, for sensible areas, or if you want to create a sort of easy and real-time database, you can do that. So you work on site, you scan your reality, then you move to your office and you start processing the data inside the Aeron Desktop software. Aeron Desktop is the software in which you manage the Aeron raw data, point cloud. You build up the trajectory and you can optimize the trajectory. You optimize all your point cloud and then you can create your model. So all the raw data elaboration is done inside Aeron Desktop. And this is Close, is a software in which you import only Aeron data. Then for advanced processing, you pass inside Reconstructor, that is always a software developed by Jexcel, in which you can carry on what we do, the advanced processing. So point cloud editing, denoising, you can create meshes, you can extract a different kind of output, like for example, I don't know, 2D orthophoto, you can calculate volume, areas. So it's a big software in which you can start extract your deliverables. And then you can export the data to third-party software. And this is another thing which is very important because we know that users are used to work in different platforms depending on the needs. For example, you can enter inside Recap, so access to the Autodesk environment, and in Recap, you can import the point cloud with the panorama pictures. You can export for cloud sharing platform. We will see then the integration with Scene2. You can move inside some specific modeling software like Edgewise, Verity, or you can enter inside specific platform for mining, management, data mine, Surpack, etc. Or you can even use one of our tool that is one of the first level of sharing that we have, that is the Go Blueprint, and we will experience later on this Go Blueprint, in which you can share, analyze, and use this 2D X-ray map for measurement, annotation, and some analysis. So just to resume, which are their own benefit? First of all, you can have a global view, so first view and comprehensive view and knowledge of the site. It supports the collaboration because, as Daniel have said before, there are many actors who work in project, and so by Aaron, you can collaborate with all of these actors. It provides a high accuracy of your model that you can keep under control during the process. It allows to share the data in a different platform. It also enlarge and increase a lot the productivity because it's fast, so it permits to save time on site during the post-processing. And it also provides a sort of scalability in terms of long-term data management. It increases the efficiency, as we have said before, and it allows you and it supports you also to plan your future activity and also your project on site. Let me quickly open this Go Blueprint, which is one of the first level of data sharing. I think that with our solution, with Aaron's solution, you can have 3 level of data sharing. So the very first one is the possibility to share this 2D.5 map, this blueprint. I will try to open very quickly this tool. This is a very nice tool because you can work with this tool on your desktop or also on a Microsoft tablet. So you can share basically a 2D map like this one that can be created in the orientation that you want, a plan view, a section, a facade, it does not matter. You can navigate on this blueprint also on site, okay? You can install this free tool on a Microsoft tablet. And basically what you can do is taking measurement. I very quickly change some parameters here. So you can create, for example, I don't know, taking measurement, which are, for example, a line. You can change, of course, the decimals. You can also calculate area very easily, just to show you an example here. And what is nice is that in reality, this blueprint, this X-ray orthophoto is not a 2D one, but is a 2.5D because it kept the depth information. So you can easily know the depth, so the altitude of your site, okay? Then what is nice is that you can export this one, for example, to AutoCAD, so you can enter inside AutoCAD directly if you want to create your drawing or something like that. So I just go back to the presentation. So this is the first level, we can say, of data sharing. The other one level of data sharing, which are 3D data sharing, I'd like to enter showing you some projects. So the first one is a project that has been carried on by Metropolitana Milanese, which is a big company that manage all the some public building, the subway in Milano. And this is a project in which the company has to scan more than 500 buildings for social housing. So it's a project that has taken 2 years, okay? And the goal was scanning all the public area of the building. That means stairs, corridors, facade, gardens, park, in order to create a documentation, a knowledge, okay, of the site, and also to create then a basis on which starting to make all the new project. We will focus on a building, okay, because we do not have the time to see more. And this building, it's pretty nice because it's a building, we can say, yeah, a building that is created by 5 buildings. So it's a merge of building. And in this project, the municipality of Milan works together with 2 different hospitals, big hospital in Milano, in order to create an area in which people can be recovered after some event that can be, for example, going to hospital or something like that. So it's a social housing rehabilitation. It's a center for rehabilitation. And the goal was exactly to scan all this area in order to support the future development and project. So basically, this is the plan view of this area that has been scanned. So we have 5 buildings. This is the visualization of the buildings in plan view by the blueprint. This survey has been done splitting Aeron mapping in different trajectory. If you can see the different colors of the snake, which are the trajectory, is because in order to be fast, the survey has been splitted on site in different parts. And then in the post-processing, all the different survey has been merged automatically together. So what is nice is that you are free to plan the on-site activity as you like, starting from indoor, outdoor, entering, exiting, and then you can mount all this data together automatically. So this is the view with the scans, and this is the final view, always from a top view of the scan area. So in 3D, these are the building that has been scanned, and in the end, what has been created has been a 3D intuitive models in order to visualize all the building structures, especially to have the possibility to share this data to the stakeholders, especially including also not technical person, because what I'd like to underline is that we are used to talk between professionals, okay? But there is also another part of person who need to access to this data, and they are not professional like us, but so they need to have something which is fast, comprehensive, and easy to use. And just to give you some few information about the working on site time, the area has been scanned in 3 hours, and the post-processing took around 5 hours. So we can say that more or less the time between the on-site acquisition and the post-processing is 1 to 2. The result has been a model that you can navigate, and here we are inside the Reconstructor platform, so the desktop software that run on your PC. You can jump sorry, from one panorama pictures to the other. In the background, you have the point cloud. So you can take a measurement on this, and you can jump from one acquisition to the other. So you see also the same colored snake that we have seen before. These are the different trajectory. Here we are in an indoor. So this project has been also used to map the damages in the area in order to have a catalog, not only of the spaces, but also of, for example, the condition of the building itself. And we are here at the second, we can say, level of data sharing. The other important level of sharing, which really can fill the gap of moving from your desktop application up to a cloud one that can be reached from everyone, from everywhere, is the Scene2 Cloud. So the project has been shared by Scene2 in Scene2, and from Reconstructor you can enter inside directly Scene2. And this has been really appreciated not only by the technicians, but also by the person who has to make some analysis in terms of environment analysis, analysis of the space in order to plan and to project some specific activity or some specific function depending on the area. Because it enables to access from everywhere, also from your smartphone, as you know, into the project. The other project that I'd like to present you today is the integration between data from TLS, from UAV and Aeron. And I'd like to do that using this project. This is pretty nice. And this is the case of San Zeno and San Clemente churches. So these churches are located in Brescia, in which we have the HQ. Our HQ is in Brescia. And they are pretty nice because from this historical point of view, the churches are very ancient. And San Zeno, as you can see on the left, is close to the Capitolium, the Brescia Capitolium. So we are talking about Roman area. And the San Clemente Church on the right has been built in the 10th century, and then it has been modified during the time. And this church is also important because inside has got nice paintings from a very important painter, Italian painter. So the goal of the project was to document both the churches in order to prepare a financing project. So the idea is to restore these buildings, these churches, and the very first need was the documentation of the building in terms of geometry, status of the art, and also materials in order to plan all the financing project. So the survey in this case has been done by Aeron from the terrestrial point of view, moving outdoor in indoor. And then in order to fill the gap of the upper part, the acquisition has been done by a UAV. Here we can see some pictures of Aeron working indoor and outdoor. And this is the area that has been scanned. So the survey starts from San Clemente Church and then moving around the surrounding area up to San Zeno. In this case has been done two trajectory has been done. So two Aeron survey, one in the indoor, two indoor, San Clemente and San Zeno, and one only single acquisition outdoor in order to connect the two churches, evaluating also the street, okay, that were connecting the two churches. And the San Clemente Church and San Zeno Church has also been surveyed by the UAV. So the latest point cloud that you see from the orthographic point of view are the point cloud of the UAV. So this survey has taken around 40 minutes by the UAV. The outdoor area that was around 600 meters, more or less, moving around this narrow street in Brescia, took around 30 minutes. While the indoor scanning took 40 minutes, 20 minutes more or less in San Zeno and 20 minutes more or less in San Clemente. The post-processing time has been pretty fast. For the UAV, we are talking about 2 hours, and both Aeron indoor and outdoor, it took around 1 hour. So the final result has been a 3D model that can be navigated. Okay, you can jump, as we have seen before, from the panorama pictures, moving around the trajectory. And basically, this is what concretely has been done. So the very first point cloud is the Aeron one. The RGB one is the indoor, always Aeron. And then the other one has been the drone, okay, in order to complete all your survey. we use the UAV data not only to, we use the UAV data in a very smart way that I tried to introduce before, which is the possibility to use the scans as constraint. So basically, the UAV data, as we are seeing here, can be put inside the SLAM algorithm process while you are processing your raw data, and you can put everything together with Aaron, and you can use your UAV scans to optimize and to adjust the Aaron data. So instead of using the single control points, you can use what we call control scans. And this is something that is really appreciated by the users, because you do not have only a simple merging of data, but you can really increase the Aaron accuracy using your millions point coming from UAV or TLS. This project has been then uploaded into Scene2 platform, okay? So here we are looking at the Aaron data, and this is the UAV, because one of the very great things of the platform is that you can sharing all the data that you are integrated. So Aaron, UAV, and you can display in a very high level detailed. So if you have to map, like if you have to create like damages map, or even, for example, material map, you can, and you see that you can jump from the Aaron data, so the terrestrial one, to the UAV one, just measuring and making all the annotation. And what the user like is that they could access to the complete project from everywhere, taking also annotation, especially considering that in a project like this one, not only surveyors are involved, but we are talking about restorers, administrative people, people who work in financing, people who work in chemistry, because they have to set up a project, a restoration project. So different actors are involved. And what they like pretty much is the possibility to access to their 3D data very easily, picking some measurement and make the consideration that they need. I came, sorry, to the end of my part, and before passing the floor to Daniel back, if you wanna, of course, having more information, contact us. We will have also time for Q&A, but if you want to contact us, we will be free to support you. If you want to experience Aaron dataset, you can go on our website. In the download section, you can download a dataset and you can play a little bit with it. I'd like to thank you guys for the attention. I hope that to have given you some, input on which thinking about, and also to give you some idea for your wish list that perhaps is different respect mine. So thank you very much. I pass again the floor to Daniel.
Thank you, Georgia. Let me just share my screen. I think we're already getting some questions.
I have a question, if I can. Okay. The question is, when you export to Recap, what you can export? Only the point cloud, the images? Okay. One question is, this is interesting. You can export both the point cloud and also the images. So basically, I tried to explain this before. When you export to Recap, or generally speaking to E57, what you can export are point cloud and even the images. And as I mentioned before, Aaron integrates a 4 lenses camera that is engineered by us. And in real time, while you are scanning, it acquires also pictures. So the pictures can be acquired in 8K resolution by single shot. So you stop and you shot, or you can acquire in continuous streaming. So while moving, Aaron can acquire a video in 4K. In both the case, you can use the single shot and also the streaming to colorize your point cloud, or better to create your model as we have seen before, in order to jump from one position to the other, from one pictures to the other. And what is pretty nice is that when we acquire the information, the color information in streaming, okay, by the 4K streaming movie, when we export, and so for example, we want to enter inside Scene 2, we can decide which panorama picture export, because Aaron acquires 24 frames per second, okay, and so in this case, we can decide when we export the length between the panorama pictures that we want to use to navigate and to visualize the model. There's another question. Can you tell me more?
What type I think that one is for you as well.
Yes, I think so, because one is what type of UV LiDAR solution was used to capturing? Well, I think that in this specific case has been used DJI. I don't remember exactly which one, but the project that I have shown before was a DJI. I can give you more details. I can tell you that we have experience also with some user who work with some quantum system, okay? So basically, you can use any kind of UAV or any kind of LiDAR system, because technically speaking, what we use is a point cloud. So when you have done your processing, your UAV processing, you have your point cloud. It does not matter if you export in E57, LAS, it's really up to you. You can take this point cloud and you can put it inside the post-processing in order to use it as reference. What is the pricing range for Aaron MS Twin Color with the software? Well, it's a nice question, and we have different kind of configuration of Aaron, and so also the price of the Aaron is different, because we have long range, that means 300 meters, short range, that means 120 meters, solution with camera and without cameras. And when we talk about Aaron, the software are always included. So it's not something that you can divide. So it really depends on the configuration. And consider that we have seen today an example of the Aaron MS Twin Color that integrates the two LiDARs. So that's the reason why we call it a twin. But we also have another configuration of Aaron, which is Aaron Light, that integrates a single LiDAR, so only single head. So to give you an idea, talking about Aaron Light, the Aaron series starts from around 30,000 euros, more or less, including the software, both the software that I present you before, the Aaron Desktop for the raw data processing and Reconstructor. Then, of course, if you want to know more, you can just type us, contact us by email, and we can support you with more details.
I will take the question from Philip. Philip, I've already answered, but I'll just put on the chat. Sorry. If anyone else was not able to scan the QR code, because Philip was asking about he wasn't able to scan the QR code for the trial of Scene 2. So I'm putting it on the chat, and if anyone else missed it, please go to that link. And I think if you could take those last two.
Yeah, of course. Yeah, there is one. Yeah, thanks, Luca. Yeah, I think that in part I have already replied, but UAV can be only with pictures. And the example of San Clemente and San Zeno exactly work in this way. It has only got pictures, so no LiDAR. we have some experience with some users who works with the quantum system. So they basically use LiDAR. So we support both, because in the end we can say that it's a point cloud. So you can use any kind of system you desire. Accuracy is and there's another question. Thanks, Simulus. And accuracy is important for measurement. Is there a snap function for the point cloud to ensure repeatable measurement? Yes, you have. First of all, you have the possibility to check the accuracy before what we say the constraint and after. That means you can process your SLAM data, okay? And in the end, you have an accuracy and you can check it. You have a report. Then when you, it's not mandatory, but if you wanted to integrate with controls, control points, or even scans, of course, you can check the final accuracy that you have after this, we can say, optimization. So you can do this.
Yeah, I think we have reached the hour. To the questions that we haven't been able to answer, we'll get back to you by email. Thanks to Gexel, to Georgia, especially for joining us today. Thank you everyone for your time and all your questions. And we'll be doing more of these webinars sorry, in the coming months. So please stay tuned to Sintu's blog as well as our LinkedIn page. And we look forward to speaking with you again. Thank you.
Thanks a lot, Daniel, for inviting us, and thanks to everyone for joining.
Bye.
Thank you. Bye. Ciao.